I am Merrick, and I did the electronics. So essentially these two pictures here show the combination of everything, and they're just, for the prototype, they're zip tied together. But so the left picture shows the main gist of the electronics. So we're using an ESP32 as our microcontroller, which controls everything, which is on the right of the left picture. And then on the left side of the left picture is our motor driver, which is a 50 amp H-bridge. Originally we had a L293 motor driver, which wasn't outputting enough current, so then switching to this one, which is overkill by a lot, but it was cheap, so we did it anyways. And then the motor works a lot better, which you can see in the bottom of that picture, which is an RS390 motor, which we might upsize in the next prototype. And then on the right side is just the battery, which is a 12 volt 1.3 amp hour battery that we got from Harbor Freight and then stripped down, and it just connected with a couple wires to the on off switch. And then the servo is shown in the bottom of the right picture, and that's just controlled using Bluetooth, and the motor's controlled using Bluetooth with a Wii controller, and that's it.
For my part of the rover, I did a bunch of designing for 3D printing. I did the axle holder for the rear wheel and the motor mount to hold the motor in place. Yeah, it was pretty simple and straightforward. Just made holes big enough in the axle holder to press fit bearings into, and then dimensioned the motor to get the right size for the motor mount.
I designed the steering and the chassis. For the steering, I just did a simple assembly with 2 cross-link pieces and 2 outer pieces that connected to bearings that were press fit into the wheels themselves. And then for the chassis, I laser cut it and added angular dimensions to the front of it to allow for a larger turn radius, and then added a hole to mount the servo into. And then we later cut out a divot in the rear of the chassis in order for the pulley and rubber bands to fit through. As you can see, when we crashed our rover, the left side of the steering assembly broke, so in our next edition, we'll be designing that to be thicker to prevent fracture when bumping other cars or objects, as well as me and Marty might incorporate the steering and the axle mounts directly into the next chassis edition, just 3D printing all of it in order to simplify the design.
So for my portion of Proto 1, I basically just ran a bunch of statistical tests on some data that we collected during our test day. Originally, I wanted to run a regression analysis on wheel diameter versus speed, or tread type versus speed, but because our wheels were not easily interchangeable, I had to run some different tests. So starting out, I ran a 1-sample t-test on our fastest lap time versus our benchmark time. We as a team decided that our benchmark time for one single lap would be 7.5 seconds. So I tested the times that we recorded against that time, and I got a p-value of 0.2566. So assuming a significance level of 0.05, we are going to fail to reject our null hypothesis, basically meaning that our sample lap times are not significantly different from the benchmark time, which is good, which is what we were hoping for. I also graphed that just to give a little better understanding, visual representation of that data. So our benchmark time is in orange and the data that we collected is in blue. And so it's pretty easy to see that we were pretty close to that benchmark time. I also took some descriptive statistics on our lap time, and I used those statistics to find our coefficient of variation, which is basically just the mean divided by the standard deviation, and I got a percentage of 9.25, which is less than 10%, showing that we have a very consistent performance and low variability. I ran a correlation analysis for motor temperature and acceleration and got a value very close to 0, meaning there is no correlation between motor temperature and acceleration. all the other small tables that are kind of on the outskirts of my data is basically just where we recorded cornering tests, our top speed, and our acceleration tests, so it was easier to find the average that way. Yeah, so that's what I did, but in the future I would like to run a regression analysis where I can change some sort of factor of our rover to see how that impacts speed.